students, welcome to grade 10th chemistry class. Today in this session you are going to learn about metals, nonmetals and metallurgy, the chemical properties of metals. In the previous session you have learned about the physical properties of them. Now today in this class you are going to learn about the chemical properties of metals. Now let's get started. Now let us learn the chemical properties of metals through activities. The first activity is take a magnesium ribbon and some sulfur powder. Burn the magnesium ribbon, collect the ashes formed and dissolve them in water. So here in this activity you have to take a magnesium ribbon which is white in color and sulfur powder which is yellow color. Burn the magnesium ribbon, collect the ashes formed and dissolve them in water. So first of all, take the magnesium ribbon and burn it. You will get the ashes of them, like during the festival of Diwali, when you burn the pencil, or you'll find the powder, white ash like powder. So that is magnesium powder which is burnt. So here collect the ashes of the magnesium ribbon that is burnt and dissolve this ash in water. Then test the resultant solution with both red and blue litmus paper. So what you have to do in this activity is take a magnesium ribbon first of all and burn it. It turns to ash because magnesium burns very quickly and turns to ash. So that is a white powder. Collect the powder, that is the ash, and dissolve it in water. Test this solution with litmus paper, that both red and blue litmus paper. You can find that red litmus paper will turn to blue. So when it is turning to blue, red litmus is turning to blue, that shows that it is basic in nature. Now take sulfur powder and burn this sulfur powder. Place a test tube over the burning sulfur to collect the fumes produced. Now when you are burning the sulfur, this sulfur is a powder, yellow color powder. When it is heated, it produces fumes. Collect these fumes over in a test tube by placing it over the burning sulfur. Then to it, add some water and shake. Then you can find a solution. Now test this solution with blue and red litmus paper, and you can find that this blue litmus paper will turn to red color, which shows that it is acidic in nature. That's what we have learned, that in acids and bases, sulfur when it is burned forms sulfur dioxide, and when it is dissolved in water it forms sulfurous acid. So what we can say from this activity is most of the nonmetals produce acidic oxides when dissolved in water. So not only sulfur, nonmetals in general like phosphorus also, they produce oxide, acidic oxides when they dissolve in water. And on the other hand, most metals, they give rise to basic oxide. So the common observation, the general observation that was found is nonmetals, they produce acidic oxides when dissolved in water, whereas metals, they give basic oxides. Now here is another activity to understand the reaction of metals when they are burnt in air. Hold any of the samples of metals like copper, magnesium, aluminium, etc. with a pair of tongs and try burning over a flame. What you can observe is, it was observed that all the metals, they do not react with oxygen at the same rate. When you are taking different types of metals, different metals of like copper, magnesium, zinc, aluminium, sodium and all these metals, they do not react with oxygen at the same rate. Means some metals they react very quickly, and some metal they take time and react with oxygen. Now let's see how the reaction rate of them changes. Metals like lithium, sodium and potassium react so vigorously that they catch fire if kept open. So here it was observed like the metals lithium, sodium and potassium, when they are left open, and which means that when they are exposed to air, immediately they react so vigorously and it can catch the fire. So hence, to prevent accidents and to protect these metals, they are kept immersed in kerosene. So here, when these metals are reacting so vigorously, to protect them or to prevent accidents, they are protected by keeping them immersed, means dissolving them in kerosene oil. Now let's see the reactions of the other metals. So general observation is that all the metals, they combine with oxygen to form metal oxides. So whether it is slow or fast, all the metals, they combine with oxygen and form metallic oxides. And it can be represented in an equation as metal plus oxygen gives rise to metallic oxide. For example, when copper is heated in air, it combines with oxygen to form copper oxide, a black oxide. So here, the metal copper, when it is heated, it combines with oxygen and forms copper oxide. This copper oxide is black in color. Its equation is 2Cu plus O2 gives rise to 2CuO, cupric oxide. Then similarly, aluminium forms aluminium oxide. That is 4Al, means 4 atoms of aluminium plus 3O2. 3 molecules of oxygen gives rise to 2Al2O3. How we have to read is 2Al2O3, because Al2O3 is a single molecule. So here 2 molecules of Al2O3 are formed when 4 atoms of aluminum combines with 3 molecules of oxygen. So metal aluminium, when it is combining with oxygen, it forms aluminium oxide. So here the metals like zinc, aluminium, lead, they react at room temperatures and forms respective oxides. And these respective oxides that are formed, they prevents further oxidation of the metals. So what is the generalized equation or generalized property that was observed of metals is, metals when they combine with oxygen, they form metallic oxides. Note down children, metals when they combine with oxygen, they form metallic oxides. For example, copper when it is combining with oxygen, cupric oxide, aluminium with oxygen, aluminium oxide are formed. As we have learnt that metals have different reaction rates. Zinc, aluminium and lead, they react at room temperature, means not higher temperature are required for this reaction metals to react. These metals, zinc, aluminium and lead, react at room temperature and forms the respective oxides, that is zinc oxide, aluminium oxide, lead oxide. So the surfaces of magnesium, aluminium, zinc and lead, when they are combining with oxygen, they form the respective oxides. This oxide forms a thin layer on the metal. So the respective oxides that are formed, these oxides, they settle on the surface of the metal. So this oxide layer prevents further oxidation of the metals. So when a layer has formed, this layer will protect the metal, preventing it from further oxidation. Aluminium develops a thin layer of oxide when exposed to air. We all know that iron, when it is exposed to air, forms iron oxide. The same way aluminium, it develops a thin layer of oxide when exposed to air. So this layer is formed on the metal like a coating. So this coat makes it resistant to further corrosion, which it prevents further corrosion of the metal. This process of forming oxide layer is known as anodizing. So here a new process, that is forming an oxide layer is known as anodizing. So aluminium, when it is forming a layer of coating, that is aluminium oxide on aluminium, this process of forming the layer is known as anodizing. So here in the process of anodizing, clean aluminium article is taken as anode and is electrolyzed sulfuric acid. Then oxygen gas that is evolved at the anode reacts with aluminium and forms a thick protective oxide layer. So in this way, the process of anodizing takes place. Now, coming to the other metals, iron. Iron does not burn on heating, but iron fillings burn vigorously when sprinkled over the flame. So here, the metal copper, aluminium, they form aluminium oxides. But iron, when we burn on heating, that is when it is heated, iron when it is heated, it doesn't burn. But when you sprinkle iron fillings over the flame, then it burns so vigorously, like you can see the sparks also. So remember that iron doesn't burn on heating, but iron fillings burn vigorously. Then next is about copper. Copper doesn't burn, but it is coated with a black colored layer of copper oxide. The same is observed with copper during heating. That is, copper doesn't heat. It doesn't burn on heating, but when it is coated with a black colored layer of copper oxide, then it gets heated up. The next is silver and gold. Silver and gold doesn't react with oxygen even at high temperature. Then next is about sodium. Sodium is the most reactive metal. It is very reactive, higher reactive metal, so that it catches fire very quickly. And as you have seen that to prevent it or to prevent the fire accidents, it is protected in kerosene. Students, it's very interesting to know the chemical properties of metals and the nature of the compounds formed during a chemical reaction. For example, here when you see that metals, when they are combining with oxygen, they are forming the respective oxides. So here again, these oxides that are formed will be of a different type. For example, metal oxides, as we know that they are basic in nature. Metals, when they combine with oxygen, they form the respective metallic oxide and it is basic in nature. But it was observed that some metal oxides, some metallic oxides such as aluminium oxide, zinc oxide and oxides of copper, tin, lead and beryllium, they show both acidic as well as basic behavior. So here in general our assumption will be that the metallic oxides are basic in nature and non-metallic oxides are acidic in nature, like phosphorus, sulfur, carbon, all these are acidic in nature. When the respective oxides, when they dissolve in water, they form the acidic compounds. But it was observed that metallic oxides, some metallic oxides like aluminium oxide Al2O3, zinc oxide ZnO, oxides of copper, that is cupric oxide CuO, tin stannum, its oxide SnO, and lead plumbum PbO, beryllium oxide Be2O3. These compounds, that is these metallic oxides, they show the dual nature, that is both acidic as well as basic behavior. Such metal oxides which react with both acids as well as bases to produce salt and water are known as amphoteric oxides. So these compounds, they react with acid as well as base and form salt and water. Whether it may be the reaction with acid or a base, they form salt and water. Now let's see an example for this. Aluminium oxide reacts in the following manner with acids and bases. Al2O3, that is aluminium oxide, when it combines with hydrochloric acid, it forms AlCl3, aluminium chloride, along with formation of water molecule. The same aluminium oxide will also react with sodium hydroxide, a base, and forms sodium aluminate, NaAlO2. Sodium aluminate formula is NaAlO2. So it forms aluminum oxide forms sodium aluminate when it reacts with sodium hydroxide, a base. Along with that, water molecule is also formed. So here the common observation is that metallic oxides of aluminium, zinc, copper, tin, lead and beryllium, they react with acid and base and form respective salt and water. So here these metallic oxides, when they dissolve in water, what happens? Let's see. So here the chemical properties which you are learning are connected to one another. The first thing is that when they are burnt in air, they burn and some do not burn, and next one is that when they are heated in presence of oxygen, what happens? So here when they are heated in presence of oxygen, some will burn so vigorously like sodium and potassium, and some they take time and then burn. Now here these metallic oxides whichever are formed, their nature when you are trying to study, some are basic in nature and some metallic oxides can show both acidic and basic nature, and such oxides are known as amphoteric oxides. Remember the word amphoteric oxides, which means that the metallic oxides which can show the dual nature of acidic and basic behavior. Example of amphoteric oxides are aluminium oxide, zinc oxide, cupric oxide, tin oxide, lead oxide and beryllium oxide. Now let's see the nature of them, that is the nature of metallic oxides. Not only amphoteric oxides, all the metallic oxides and the solubility in water. Most metallic oxides are insoluble in water, but some of these they dissolve in water to form alkalis. You have learned already in acids and bases chapter. That is metallic oxides which can dissolve in water are known as alkalis. Sodium oxide and potassium oxide dissolve in water to produce alkalis as follows. Example, Na2O, that is sodium oxide, dissolves in water and forms sodium hydroxide. The same way potassium hydroxide K2O dissolves in water and forms potassium hydroxide. So what you have learned till here is metallic oxides. Generally they are basic in nature, but some metallic oxides are amphoteric in nature. And coming to the nature of metallic oxides is they are insoluble in water, but exceptions are sodium oxide and potassium oxide. They dissolve in water and forms alkalis. Now, here is the next activity to know the reaction of metals with water. So to study in detail the reaction of metals with water, here the reaction of metals, not metallic oxides. We are trying to study the reaction of metals with water now. So the activity is take small pieces of samples, that is the metals like sodium, magnesium, aluminium, all this, in beakers that are half filled with cold water. So here when you are trying to study the reaction of metals with water, again it can be cold water or hot water. First we'll study with cold water. So here when metals are taken and made to react with cold water, Metals such as lithium, sodium, potassium, rubidium, cesium and francium, they react violently with cold water. Means they react very immediately with cold water. And metal like magnesium shows slow reaction with cold water but vigorous reaction with the hot water. So even here also there is a variation in the nature or the reaction of metals with water. So the reaction rates of metals with water changes from one to another. So you can say that metals like lithium, sodium, potassium, rubidium, cesium and francium, they are vigorous with cold water. Whereas magnesium is slow in reaction with cold water but very vigorous with hot water. The reaction of calcium with water is less violent, means it is very least reactive with water. The heat evolved is not sufficient for the hydrogen to catch fire. So here during this reaction, some amount of hydrogen gas is released. When metal is reacting with water, it forms the respective metallic oxides and hydrogen gas is released. For example, calcium, when it reacts with water, it forms calcium hydroxide and hydrogen gas is released. So here the evolved hydrogen gas cannot catch the fire because heat evolved is not enough to catch the fire. So calcium starts floating because the bubbles of hydrogen gas they formed stick to the surface of the metal. So during this reaction, calcium when it is combining with water, calcium hydroxide and hydrogen gas is released. But this released hydrogen gas cannot escape. So it gets stuck to the metal, that is calcium, and due to this hydrogen gas the metal also starts floating over the water. Now magnesium doesn't react with cold water as we have seen in the previous slide. Now magnesium doesn't react with cold water, it reacts with hot water to form magnesium hydroxide and hydrogen. It also starts floating due to the bubbles of hydrogen gas sticking to its surface. So here when the metallic hydroxides that are formed during a reaction of metal with water, these metallic hydroxides and the formed hydrogen gas stays together. The hydrogen gets stuck to the metal and it cannot escape from to catch the fire. So these metals, calcium and magnesium, they start floating on the surface. So here the least reactive metal is calcium with cold water, whereas magnesium is least with the cold water but vigorous with the hot water. Now let's see the reactivity of metals which are very least in reaction with water. Metals like aluminium, iron and zinc do not react either with cold or hot water, but they react with steam to form the metallic oxide and hydrogen. So here metals like aluminium, iron and zinc, they do not react with hot water or with cold water. They don't react with either hot water or with cold water, but they react with steam to form the metallic oxide and release hydrogen gas. For example, aluminium 2Al plus 3H2O gives rise to Al2O3, aluminium oxide, and hydrogen gas is released. The same reaction can be observed with iron, that is 3Fe plus 4H2O gives rise to Fe3O4, aluminium oxide, plus 4 hydrogen molecules. So here metals such as lead, copper, silver and gold, they do not react with water at all. These metals, at least they are showing reaction with steam. They may not react with hot or cold water, but they can react with steam like aluminium, iron and zinc. But metals like lead, copper, silver and gold, they do not react with water at all. So due to this reason, They are used for different purposes basing on the properties of them. They are used for different purpose, like as you see silver and gold due to the properties of ductility, and aluminium malleability properties. The usage and the purpose of them changes. So now you must have understood why we are learning the properties of the metals. Basing on the behavior and the physical and chemical properties of them, they are molded for different purposes. Like copper, due to good conductivity, it is used for cookery, and due to its ductility, it is used as wires. Silver and gold, as they are do not react with water at all. They are used for different purpose like in the ornaments and all. So here we can see that you have studied that metals like sodium and potassium, they react very vigorously with water. Calcium may not be as vigorous as sodium and potassium, but it is less violent to water. Aluminium, iron and zinc, they react with steam. But metals like lead, copper, silver and gold, they do not react at all with water. And the reactivity of the metals with water can be compared in this way. That is, potassium is the highest reactive metal, then sodium, then lithium, then calcium, magnesium, zinc, iron and copper. So here you have seen the reaction or the reactivity of metals with oxygen and with water. But these two chemical reactions are not enough to categorize or to know the complete chemical nature of the metals. So here in the further class you will be learning about the other detailed reactions that are involved to categorize these metallic oxides or the metals. Okay. So with this, I close the session for today. We'll meet you soon in the next class. Thank you.